Let's review one of the questions off of the clinical theory exam. The question states, you respond to a cardiac arrest and discover that all the preloaded epinephrine syringes are missing. Only the 1 in 1,000 ampules are available. Which of the following options would result in a proper ACLS dose of epinephrine for an adult patient in VF? All right, first piece of information you need to know is what is the dose of epinephrine for an adult patient in VF? So the dose is 1 milligram, okay? A patient that's in VTAC, pulsus VTAC, or VF, they're going to get 1 milligram of epinephrine. Most preloads come in the formulation or concentration of 1 in 10,000. 1 in 10,000 is the same thing as saying 0.1 milligram per mil. Okay? They're telling us in this question that all of those preloads are gone. We don't have them, they're expired, they're gone. So we have to mix some drug using 1 in 1,000 to get the same dose of 1 milligram. Now, 1 in 1,000 epinephrine is 10 times stronger than 1 in 10,000 epinephrine. So if 1 in 10,000 epinephrine is 0.1 milligram per mil, 1 in 1,000 epinephrine is 1 milligram per mil. So let's break this down. How much epi would I need to give to get 1 milligram of drug if I was giving 1 in 10,000? Well, if I was giving 1 in 10,000, you would need 0.1 milligrams over 1 mil equals, I want to give 1 milligram. How many milliliters is that? And if you work that out, it turns out that X is 10 milliliters. So 1 mil times 1 milligram divided by 0.1 milligrams, the units cancel out, we get a volume of 10 mils. Okay, so if I take 10 mils and I multiply it by 0.1 milligram, I get 1 milligram of drug. And that's why our preloads are in the volume of 10 mils. Well, if I do the same thing here with 1 in 1,000, I've got 1 milligram per mil now. I still want to give 1 milligram. This one's pretty simple. The math works out to 1 mil drug. Okay, so I give 1 mil. I'm giving 1 milligram. Now, these seem pretty straightforward. You just have to keep these ratios in mind when you're solving this question. So let's pick apart these options. Option A, we've got 50 mils of saline, and I discard 5. So let's just actually erase that. All right, so I got 50 mils of saline. And the question, or the option here says we discard 5. So what are we left with? 45 mils of saline. Then you add, so we add 5 mils of 1 in 1,000 epi. So we're adding this guy. So 5 mils of this concentration. So our total volume is back to 50 mils, and inside that 50 mils we have 5 milliliters of epi. Well, what is the concentration now in that 50 mils? Well, it's pretty straightforward. If we now say that 1 in 1,000 is 1 milligram per mil, so 1 milligram per 1 mil, how many milligrams is in 5 mils? Okay, solve that out. X equals, obviously, 5 milligrams. So there's 5 milligrams of drug now in this 50 mils. The question then goes on to say we're going to give 10 mils of this to our patient. So I guess a good way to think about this is how many milligrams per milliliter are we going to give? So if we have 5 milligrams of drug total in 50 mils, we have 5 milligrams divided by 50 mils. Our total per mil works out to 0.1 milligram per mil. So 5 divided by 50 is 0.1. Now we drop 10 mils and administer it to our patient. So 10 mils of 0.1 milligram per mil. Units cancel out. Our answer is 1 milligram. So that actually turns out to be right. So we've got the dose that we're looking for is 1 milligram. By taking 50 mils, withdrawing 5 of it, and adding 5 mils of 1 in 1,000, we've made the same concentration as our preload. We've made a little mini bag of 1 in 10,000. So our concentration is 1.1 milligram per mil. If we take 10 mils of that, we're giving the proper dose. So A turned out to be right. Let's just go through the other ones just to make sure this is clear. So B, in a 20 mil syringe, we mix 10 mils of saline. So 10 mils saline plus 10 mils of 1 in 1,000. So now our total volume is 20. And of that 20, 10 mils is of epi. 1 in 1,000, again, 1 milligram per mil. So we've got 10 milligrams in this solution. So we've got 10 milligrams per 20 mils, or 0.5 milligram per mil. So if we read the question that says drop 10 mils and administer that, so 10 mils times 0.5 milligrams per mil, cross out your doses, you're now giving this patient 5 milligrams of drug. That's 5 times overdosed, okay? So B is wrong. C, obtain a 100 mil bag of D5W and add 5 mils. So we've got 100 mils, we add 5 of 1 in 1,000, and mix it and administer to the patient. So now we've got 5 mils of 1 in 1,000. That's the same thing as saying 5 milligrams. Remember, 1 milligram per mil. 5 mils would be 5 milligrams. So our total volume here is 105 mils. Of that, 5 milligrams is drug. So we take 5 milligrams divided by 105 mils, and we get roughly, what is that, 0.47-ish milligrams per mil. Now, this doesn't actually even tell us how much we're giving. So by the way the distractor reads here, I would assume we're giving the whole volume, which would be 105. So that times 105, well, it's just going to give us back this 5 mils. So we're going to be giving 5 milligrams of drugs. So overdose. Last option, D, obtain a 30 mil ampule of 1 in 1,000, draw up 3 mils of 1 in 1,000, and administer directly to your patient. Well, if 1 mil equals 1 milligram, 3 mils of 1 in 1,000 equals 3 milligrams. So we've given our patient 3 times overdose. The point of this question was just to get us thinking about drug calculations, and the key here was knowing our dose for epinephrine. Hopefully this helps with some of the ideas of how to switch concentrations and calculate some of your drugs. Hopefully this has helped.